Yeah, good evening, Jyoti. Good evening, Ajit and Tanya. Let's wait for a couple more minutes for more people to join. All right, so it is 5:55. We'll get started. Good evening once again, everyone. Can someone confirm if the screen is visible?
Yes, I can see.
All right, so today's is contact session 2 for Devops for Cloud. So quick recap of the class guidelines. So we will start the class at 5:55 as we are starting now. And yeah, it'll go on till 6:45. So if at all I do not give you a break during that time, please remind me. And we'll take a quick 10 to 15 minutes break and then continue again from 7 to 7:50. So recap wise, I think we'll for every session I try to do this wherein we recap the key things, key concepts that we discussed in the previous lecture. So I'll do that for the first 5 to 10 minutes. And if you have any questions in that, you can ask then. So I'll basically be skimming through the slides of the previous lecture. So we'll do that. And the agenda for today's session is to talk about all the process models we have. So we'll be talking about before agile and after agile models as well. So starting with all the way to waterfall model, we'll understand what it is, the pros and cons, and then the V model, iterative model, and spiral model. We'll take and look at like some of the real world examples of organizations that have used these and the pros and cons of doing that. And then we'll get introduced to agile methodologies, wherein we'll be talking about what is Scrum, what is extreme programming, and also talk about TDD, FTD, and BDD in agile context. Right? So if time permits, we'll touch base on the dimensions. If not, we'll take up in the next class. Right? So this is the agenda for today's class. So let's quickly try to do a recap of what we discussed in last class. Right? So last class we basically have discussed or have given you a walkthrough of the handout and what all things you can expect from the course and all the tooling that you would be learning uh, across throughout this course, right? So, and then we tried to look at some of the textbooks that you can refer to and the reference books. And this was just a glimpse of how would the slide content would look like overall. So we'll get to all of these. And then we started to understand what is DevOps, right? So this is a continuous process, and more importantly, the aim of DevOps is the key takeaway from last class, which is to shorten the so-called SDLC or software development lifecycle. So if you want to shorten the SDLC at the same time maintain high code quality and ensure there is continuous delivery to the customers, which means we may have to establish and have a well-defined process for the software development lifecycle itself. And at the same time, for each of these stages of software development lifecycle, we need to streamline them, automate them as much as possible, and have a pipeline for them. Right. So that's the end goal of uh, a DevOps team. And DevOps itself was formed as two teams, primarily like software development team and the operations team. But like we discussed, even the QA team these days is merged into the development team. So you have both uh, developing the code and testing the code as one team, and then you have the packaging team, which is the operations team. Right. So all of three working together. Coming to the software development lifecycle itself, we started to look at the six stages in more detail. So the first thing that happens is the product managers. It's the planning phase wherein they talk to the potential customers or existing customers. If let's say the product has already been launched and they are looking for enhancements to the product, so they may reach out to the existing customers. Or if it's something that they want to develop as a first version of the product, then they may reach out to the potential customers. Or sometimes if customers are not readily available for that product, right, they may do some market surveys and analysis wherein they try to figure out what are typical expectations from customers for that particular product they have in plan, right? So they try to gather all of that and try to write a business document for it in the name of BRS or business requirements specification. Right. So that is as part of the planning stage. Once the requirements are specified, we discussed in the last class that they are made up of two types. One is functional requirements and the other is non-functional requirements. And then we discussed about the second phase, which is analysis stage. This is where the business analysts talk along with the subject matter experts and the architects to convert those business requirements, the functional and non-functional, into technical requirements. So at the end of second phase is where we get some technical requirement specification or TRS in short. And this specification using this is where in the third phase, the designers come into picture wherein they design, look at this high level design document, which is the technical requirement specification, and try to come up with the high level design and low level design. And then the developers come in to implement this and write code for it, right? So I think this is where we left off in the last class. So let's go through this. Before that, any questions from the previous class, please let me know. And um, yeah, so this is the agenda for today's class. Otherwise,
I have one question here on
yes,
the
Ajit.
design and implementation.
Okay,
The same set of the people is going to be part of design and implementation, or it's a different set of people that do the task.
okay.
And
Yeah, good question and point. Usually, the preference is that the designers are different than the ones who are developing. Right? The developers and the designers are usually separate in most organizations. And in fact, the levels of these people are also different. What I mean by the level is the uh, role, the development role that they are at. So usually the senior folks are involved in the designs, like maybe SD2, SD3 level, and SD1 level or interns are the ones who usually do the development. Right? So the reason for that is these SD2 or 3 senior folks would have been developers when they were in their initial roles, right? And that way they have that experience hands on, and that's how they'll be able to write a design which is, at the end feasible to implement, right? So, uh, and the reason for having them different is because um, there is usually something called a bias, or some level of uh, details would be missed out if it's the same person who does the design and development, and it's not so good for the organization and the product, right? Because unless the people are different, they wouldn't be writing these designs in more detail in such a way that you know at the end it is maintainable, right? Like someone else who tries to pick up, let's say, a bug on this particular feature or an enhancement to this particular feature, they'll be able to understand only if the document is clear enough, right? And if it is the same person who does the design and development, usually those they skip the details in the interest of time, or in the interest of the deadlines that they have to meet, right? And if it's different people, only then there is some validation of the design that the first person has put forward, and there is also a proper documentation for maintainability for future. Does that make sense?
Yes. Does it mean like
Yes, sir.
architecture is also a part of design, or it's comes before the design?
Yeah, it comes before the design. So usually designs are for a specific feature at hand, right? That is planned. Whereas architecture is more like uh, at the high level how the product should look like and how the data flow should happen for that product. Like what are the sources, what are the sinks, and what are the key components that are involved. Like, do you need a database? Do you need a high level components, like the what should be the front end, what should be the back end, the technology, choices, exploration, and all of that is high level design and blueprint. It's in some organization it's called a blueprint or so. So basically it's very high level and not ready for, I mean, looking at that we cannot really write code because there are some implementation details that are missing, and it's intentional because the focus is more on getting the end-to-end flow for the product right, and it's high level.
Yes. Yes.
And then comes the low level design, which is more closer to the code, which usually involves like the for example, in Java based projects you have something called design patterns, right? Wherein like strategy pattern, or you have a bunch of design patterns which are good practices. And basically design pattern is more like a well-known solution to a well-defined problem, like something that previous engineers have already faced and have documented that this is something that works, right? For example, if you have some properties files, what is the best way to read those properties files? There may be a design pattern, which design pattern is nothing but a bunch of problem statement and solution given a particular label, right? So those best practices, coding practices, and all that are more clear, and exactly which class file, for example, in Java case, to write, what method name to have, what should be the method signature for each of these methods, right? The input and the output for each method and so on are written in the low level design, right? So it's more closer to code and helps you actually write code looking at it.
Okay. Okay. Thank you.
Yeah. Yeah. Yes, Devi Prasad. Yeah. If you can go next.
Hello, Sai. My question is DevOps culture still in the practice? Because as far as I know, it has been diversified into different areas such as SecOps, MLOps, and platform engineering. So, in this course, are we going to cover the diversified nature of DevOps? Because
Yeah.
the name DevOps, it's been, I think, more than 10 years or maybe 15
Yeah.
years it's been.
Yeah.
I know it's not gone, but
Mhm.
how much it is relevant to the current day or current times? Maybe if you could cover and give a brief context.
Sure. Sure. Yeah. Yeah. Very good question. And yeah. So I think this course, as the name suggests, it's focusing on DevOps concepts, right? And this, like you said, has been diversified. Uh, I should say it's kind of made more specialized in each of those fields. For example, the ones that you had quoted, like ML ops, AI ops, and we have data ops, and so on. So I think in the handout as well, these in general together are referred to as X ops. right? X could be ML, X could be AI, X could be data ops. And these are like specialized fields of or subfields of DevOps uh, based on the particular product or use case that they are working on, right? So if it is revolving more around the data management part of it, it is data ops. Data as in like these days it's big data, high volume of data, and there is variety of data, there is volume and etc. Right? So there are various attributes and characteristics of data. So how do we maintain something like data lineage and other things is what data ops focuses on. And ML ops is basically same DevOps, but you're now using machine learning algorithms instead of traditional algorithms, right? So the software development cycle, what software they develop is not uh, the software, for example, like for maintaining an e-commerce website like Amazon, you may write the front end code, the back end code, and the database related access code and so on, or you may have cache related code and so on. So these are still there. So DevOps is still relevant and there, and DevOps actually is the fundamental or foundation for all of these, right? It's a super field that is more generic for anyone to actually learn and get into. Whereas these that we talk about, and these are actually covered as well in the handout. If you see, I think session 15 or so is where we'll spend time on ML ops and data ops. So these are like extensions. That X actually stands for extension of DevOps, wherein we are applying DevOps now to specialized fields, right? So the concepts that we learn from this course are still relevant and actually are superset of what you would otherwise learn from all of the other extensions.
Thank you.
Thank
Welcome.
you.
So, yeah. Okay, Yash has a question. Please explain these roles also once site reliability engineer and DevOps engineer. Yeah, I think yeah, maybe this particular topic, like wherein again, I think it's there in the handout where we around session contact session 16 or so, wherein we talk about what is the future and what are the next steps from this course. I think there we can talk about what all job roles you can target for, given all the concepts we would have learned by then. I think it's better I take up this question towards the end of the course or maybe mid sem, because by then you would be exposed to certain concepts that they then can refer to. Right now, I'm not sure if I pick up any topic if you're already familiar or not. So I think it's more relevant if we do it towards the end, wherein I can talk about like what all job roles are there in the market, and with the concepts that we have learned so far, what all roles you can target for. Yeah, thank you. All right, so we started to understand the software development lifecycle, the each phase of it in more detail. So the story so far is that the product managers have met with the customers, either existing or potential, and try to identify like what are the key features that they should have in the form of functional and non-functional requirements. And that requirement analysis is done by the business analysts and architects to come up with the technical requirements, and then the designers have come in to convert those high level architecture diagram documents into high level design followed by low level designs. And eventually then we have the developers coming in as part of fourth stage here, the implementation phase, wherein they write the source code for this, they write the unit test cases for this. And then comes like once the code is written by them and unit tested by them, then they make it available for the testing, further testing. So earlier we used to have a dedicated team like quality assurance team or testing team as a separate one. These days it's all integrated. So few members of that team, if they were involved in the development, the other few are involved in the testing now, right? So that way it's a shared responsibility. And Eventually, the code also has to be promoted from the development environments where the development is done to testing environments where the test can be done, right? So here is where we end up packaging the source code. If it is a Java project, we end up packaging it as a jar file. If it is a containerized application, we package it in the form of a Docker image. If it's if it's a Python based project, maybe we package it in the form of egg earlier or wheel these days, and so on, right? So there are various formats in which we can package this and then promote it for testing. And the same packaging that we do here is what shipped to the customers as well once the testing is done. Right. And finally, once the testing is done, and let's say the artifacts that the development team has generated are certified by the testing team, that is where they are deployed onto the customer environments. And then comes the last phase of DevOps, which is maintenance, right? So once we deploy some code and software onto the production environments of customers, the DevOps role doesn't end there. DevOps role is still there, wherein they have to provide the ongoing support of maintaining it. Right. So when we talk about maintenance, it's more about continuous monitoring and observability. So we keep monitoring for any ongoing bugs, issues before the customer finds, right? So it's always good idea to find issues ourselves first as a product team offering the product before the customer finds, right? And usually any downtimes, maintaining the health of various systems that are part of this and so on are tracked, and alert systems are set up so that we act before and uh, essentially provide high availability for the customers and also scalability for the customers. Right, so there should be zero downtime. Our application should always be available, highly available, and so on. So all the abilities like we discussed in the last class come under non-functional requirements like reliability, maintainability, scalability, high availability, and so on. Right. So those are still done, and let's say we find some issues or bugs, then again we plan for it and analyze it and do the design and implement it and roll it out, right? So that is why how this is a kind of a continuous process. Right, so where does DevOps come in here, right? This is a typical software development life cycle wherein the architects, the designers, the developers, the testers are involved at various stages, and even the product managers are involved during the requirement gathering and so on. So where does DevOps engineers come in here, right? So uh, I mean, this is something that is taken from the textbook as well, this particular statement wherein they say treat ops as your first class stakeholders and get their inputs too, right? So usually what happens is most organizations involve DevOps only when the towards the end of the life cycle, wherein they are ready to promote the code from development environment to test environment, or from development environment to, I mean, once it is tested to the staging or production environments of the customer, right? So only when we have to migrate the code from one environment to another is where usually the DevOps is involved. But the best practice here, and which is more practical, and I think now that we are discussing about this, I think you should also see that if your organization is not doing this, this is something that you have to apply in your organizations as well. That DevOps team should actually be involved right from the beginning of the software development lifecycle, because they also need to plan based on your product and offering what all infrastructure to set up, what all infrastructure meaning the databases, the servers, etc., that you would need for your development, for your testing, as well as for production, right? So they also need some time to understand the product architecture and also come up with right tooling to support each of these. So yes, Devi Prasad, please go
I have a question specific to the testing and integration. So the scope of testing has been very broader in the sense We have performance, integration testing, functional testing, chaos testing, and so on. So in the continuous integration kind of a setup,
Yeah.
how do we factor the continuous feedback when the testing is not just the functional testing any longer, but we have lot many other aspects of testing? How do we collect the feedback, having the continuity in place without breaking the feedback loop? It's always been a very myth to me. How come testing and integration been very simple in the continuous integration pipeline?
Okay. Yeah. Yeah. Good question again. So generally the um, ideal goal or the actual uh, goal of this stage is to, like you have pointed out, do various types of testing involving like functional testing. There is also this integration testing, and we have like, I think, monkey testing, donkey testing, and so many other types of testings that we have to do. The key, I mean, I think the reason sometimes some of these are not factored in, or the feedback of it is not captured correctly, is because most of these are still manual in many organizations, and they rely on the people to do these, and so some of these. I mean, they may be in the process of automating it, but most of these are manual, and when it comes to that, it's not easily repeatable or scalable, right? And it is those are the bottlenecks wherein sometimes, in the interest of rolling out or meeting the deadlines for the release or so, they try to not care so much about these feedbacks that we get from each of these tools. But ideally, as a DevOps engineer, and I mean, eventually a DevOps architect, solution architect point of view, it should be more like, how many of these tests can we automate and also have the feedback provided as part of the CI cycle itself, so that it is consumed and you kind of establish like release gates. These are called release gates, that you close the gates if they don't meet certain criteria. Right. So from the feedback of these, we try to then categorize like how many of these issues are actually high priority issues or medium and low. And maybe you can have a gate that says, if there are critical or high level issues, let's not even promote the code further for further testing, right? So it's more about establishing and refining the pipeline to factor in all of these tests, and at the same time have it as much as possible automated, so that there's no human intervention needed, and the feedback also can be accordingly captured and is integrated as part of the pipeline.
Yeah, I think theoretically looks fine, but I'm sure it is challenging when it comes to the implementation. Having all these tests and release gates, it will only create a bottleneck for the release promotion, is what I can think of. Anyway, thank you.
Yeah,
Got it.
yes. Yeah, that is there, but I think as part of our assignments and the ongoing demos that we will try to do in this course, you would see that most of these tests could actually be automated, and we would start from scratch and see like how each of these tests could be integrated into the CI pipeline, right? So uh, this course gives you the way of how we could probably integrate all of these and automate these into the pipeline. But yeah, it's up to the respective organizations and their higher management to actually ensure that these all are integrated into the pipelines and are automated, right? So some of these, for example, even if they were to be manual, there are tools like Selenium and others, wherein, or these days there is, in Python you have something like Playwright, which basically you show to it like how manually these things can be done to it, and it will generate the code for us, right, to automate this and integrate with the pipeline. So there are ways to do this. And yeah, traditionally people were, yeah, involved in to do the testing manually, and so I think we are slowly shifting towards automating this. And now that we have these generative AI tools as well that help us generate the code, I think it should be more and more easier to automate these and integrate into the pipelines. Right. So let's proceed further. So then this is SDLC, and like we discussed during the requirements phase, while product teams are involved in understanding what is the business requirements and how to convert them to technical requirements and so on, DevOps needs to start planning for what kind of infrastructure should they provide for various types of environments like dev, test, staging, prod, etc., and the tooling needed for each of these tasks to basically try to then plan for automating these and use the tools and establish the pipeline, right? So even from DevOps side, they do the same, like in parallel to these. They also design like what should be the right pipeline for this, the sequencing of actions to be done here, and so on. And then they, during when the developers are developing the code, they need to build tools to support this CI pipeline. Right. So, for example, uh, Jenkins, if at all it's a choice for building a CI/CD pipeline, then they need to have the pipelines configured and defined in Jenkins, that once they receive this code in from some checked in by the developers into a version control system, they need to check out that code, maybe package it using some build tool like Gradle or Maven for Java projects, and maybe run some linting tools and packaging tools. So all the build tools that are needed to support the CI process is something they have to develop in parallel. Right. So as you can see here, throughout this SDLC, DevOps also have action items to be done in parallel. So that's usually the case where DevOps are integrated. Like I said, most organizations are still not doing this. They only involve DevOps towards the end, where development is done and they have to promote this, and thereby give very less time to DevOps to you know automate all of these or do better at these. But if you were to involve them right from the beginning of the SDLC, I think they also would have sufficient time to come up with the tooling and pipelines to automate this and have it end to end. Right. So then comes testing. Even in case of testing, once let's say the actual functional test cases are written by the testers, it's more on the DevOps side to trigger these test cases in a automated fashion, right? So whatever are the functional, non-functional, and integration tests and various types, DevOps should provide sufficient tooling and infrastructure to run these test cases as part of the pipeline. And why we want to automate this as much as possible is it's reliable, that you can there is no human intervention or misconfiguration done. Whatever configuration is done for one version of the product is the same that is done for future versions of the product as well. So it's more reliable, and it's repeatable, that you can repeat it maybe daily basis or weekly basis. You keep running these tests, right? So uh, these are two reasons why we have to kind of automate and have these tests. Coming to the integration and deployment, building and supporting continuous deployment as well. So as part of development efforts, DevOps will build the CI pipeline. As part of integration and deployment efforts, they'll build the CD pipeline and thereby have the both CI/CD ready for the particular product or project being developed. Right. And finally, as part of maintenance, they need to build monitoring tools that keep monitoring the health of various components, generate alerts, have detect issues, and so on. Right. So we'll talk more about this as well, the continuous monitoring and observability, I think in context session 12 or so, right? 12, 13 or so. All right. So let's move forward. So to in order to concretize this more, I mean, we have been discussing all of these phases, but to give a specific concrete example and also easy example here to understand all of this, let's look at calculator as a example. Like imagine you are building a calculator. I mean, the please don't go by this example or the nameness of this. The intent here is to explain more on the SDLC process and make it clear on what we mean by each of these phases, right? So let's look at calculator and imagine the inputs that we expect from the users are some two numbers that they input. right? So as part of requirements gathering, the product managers may come up with functional requirements, like as our users, as we understand, they would like to, be able to add two numbers, subtract two numbers, multiply and divide two numbers, right? Those typically, which are like features of the product that you get to see and use, are functional requirements. Whereas non-functional requirements are, it should be highly available, the calculator app should not go down, or there should be zero downtime. Even when, let's say, initial version of calculator has been rolled out, which is version 1, and then they do some add a few more features, right? Like another feature could be maybe logarithm, ability to perform log on the given numbers, or maybe perform exponential, like slowly from basic calculator, maybe we are enhancing those to provide like a scientific calculator related features, wherein you upgrade this to version 2. Even in that case, the product should have zero downtime, that the calculator is always available for the users to use, right? So that part wherein you are making it highly available is again something called a non-functional requirement, right? So this doesn't relate to any of the features that you see from the product, but this is your experience that you have about the product, right? Like this experience, also the UX or user experience, is more of non-functional requirement, because it has to be highly available. And when we talk about scalability, it's like initially, the calculator application, we may deploy it on our server or our laptop to begin with, wherein we expect the usual traffic of the users to be 1 to 100. But imagine now the calculator app became very popular, right? And so you have like thousands to 10,000 requests coming in simultaneously, right? Requests coming in simultaneously or at the same time are called concurrent requests, right? So concurrent requests are actually a challenge, because now you have to handle all of these in the same second they come in, right? So like at the same point in time, you're getting like 10,000 requests. So that single server that we may have may not be enough to handle all of these requests and produce the response, right? So usually I mean, in production, you have like a 64 GB RAM or so, right? And you also have like it's a Linux based machine, and OS wise, and you have like maybe 1 TB of storage or so on this, or sometimes like uh, organizations, I mean, it's varied, but this usually may be able to handle only, let's say, 10,000 requests which are concurrent. Then if you do get like 1 million requests from the users, you would have to scale up this single server, right? It will no longer be able to handle all of those requests, which means now we have like two ways or two choices here for scaling up. One is called vertical scaling, wherein you increase the capacity of the same server you have to higher capacity, maybe double the RAM here to make it 128 GB RAM or so, or maybe make it 256 GB RAM or so. That is one way to do this, wherein you are making it more and more powerful. So this type of scaling is called vertical scaling. Right. And there is always a limit in how much you can vertically scale, because even the supercomputer, you have like some hardware limitation as well. As you know, in your server, there are like slots where these RAM could be attached, right? Like maybe if you have only two slots, so physically to with respect to hardware, there may be limitation that you cannot scale up further, right? So vertical scaling always has a limit. And also, it's a single point of failure, meaning if the server goes down, entire application goes down, right? It's a single point of failure, or a SPOF in short. And that's how people resort to something called horizontal scaling, wherein you get more such machines. So the same 64 GB RAM that you had earlier, I mean, the one server, now you try to get more such servers, right? Server 2, server 3, connect all of these over LAN network, local area network. And then you basically now have to distribute the tasks that you get, the incoming requests. Maybe if even if they were to be 1 million, you will be able to distribute that request to each of these via using something called a load balancer that balances load on all of these, right? So eventually you're able to handle more and more user requests. right? So by the way, this is what I think initially when Facebook has done in 2010 or so when they launched, it was uh, initially launched from the laptop of I think Mark Zuckerberg, and then later on they tried to scale as and when the website became more and more popular, right? And as and when more and more users started using it, right? So they resorted to then the horizontal scaling route and attach more and more servers, right? So this is about scalability. So far, does it make sense? Like, please confirm if availability part and scalability part of non-functional are clear. Right. One last thing I quickly want to touch base on is why do we need a load balancer or what is load on a particular server, right? These two questions, yeah, I was thinking if someone would ask, I would explain, but yeah, let me do this anyways. So why do we need a load balancer in the first place, right? So let's talk about the vertical scaling case. In the case of vertical scaling, you still have your own single server. So how many ever requests come in, like request number one, request number two, all the way to request 10,000? All the requests are routed to the same server, right? Because that's the only server you have in the first place, right? So this is the server that is meant to uh, process all of these requests and generate the response, right? So here you don't need any load balancer as such. But when we talk about the horizontal scaling, right? So now we are saying we'll have like a bunch of servers, like server one, server two, server three. And as and when you keep getting these requests from R1 to R10,000, you need to now know which request goes to which server, right? Because now you have a choice. You could route the request one to server one or server two or server three. So you need to know which of those requests go to server one, which of those requests go to server two, and which of those go to server three. So that is where the load balancer comes in. So each of these requests from the user are routed to the load balancer, and then the load balancer routes them accordingly to server 1, 2, and 3. And let me make it more concrete here. Like, how do we know that? I mean, how does a load balancer algorithm work, right? So one way is it can go, it can have an algorithm called round robin, right? Round robin means like how you generally distribute the cards whenever you play cards with your friends, right? So how do we do that is we give, first of all, request one goes here, request two here, request three here, then request four, request five, request six, and so on, right? So this is how you distribute cards, and it is round robin basis, right? So you keep distributing the requests like this, right? So this is one way. And again, how do you implement this, right? How do you implement this round robin logic? Yeah, let me start with the question. So can anyone think of like how we can see that we have like request R1, R4 going to S1, server 1, whereas R2 and R5 and so on going to server 2 and so on. So the same round robin, if you can think of any code for this, like just a logic for this, yeah, please come up with. And if not, yeah, I'll anyways discuss this.
I think all modern proxies and for example, say Nginx
Yeah,
or any such proxies are equipped
yes,
to route based on the context. For example, you have file server and images based server or CDN server. So you can easily switch and segregate them in groups, and
yeah,
depending upon the context, you can route. That's one way. And also, if you have Kubernetes based solution, maybe you can have ingress or such concept to have different routing
correct.
enabled.
Yes,
And
yes. Yeah, so we can also have like API gateways wherein path-based ones. Like if say if there is an API, I mean the request has the path as like slash posts. I mean in the context of social media platform like Facebook, if they are talking about more like slash posts, you may route it to post service. If it is having slash, sign in, sign out, you may route it to authentication service and so on. So API gateway comes in there where it can allow you to route these accordingly. Yeah, you're right. And yeah, we have like from Kubernetes and from Nginx is a reverse proxy and a web server. It could do the both of these. But yeah, my question was more like specifically in this case, like how can you come up with a, I mean, pseudo logic or an algorithm that says request one four go to, let me make it more easy. Like let's call it server zero. This is server one and this is server two. Right. So how do we route like request one, R4, so on, going to server zero, R2 onwards going to server one, and R3 onwards going to server two. Right? As you can see here, the gap between these is like three requests.
Yeah, I think if we know the total number of servers available,
Yeah,
then it is just the multiples of it, like starting
correct.
from
Mm.
0 to 3 to
Yeah, correct. So how can you come up with some mathematical way to do this? So I'll try to.
a
I think
for
the same
loop.
idea. Yeah,
Mod
yeah. Modulo is the operator. Yeah, thank you, Ajit. So basically for any request number, right, like Rn, you just try to do modulo of how many ever servers you have, right? Imagine you have like k servers at hand, then you just try to do modulo of k to get the relevant server to route this to. Let's take specific example. So R1 mod, now we have three servers. So 1 mod 3 gives you 1. So you route it to server 1, right? And R2 mod 3 routes to modulo is nothing but reminder when you divide with this number. So if you divide with 3, the remainder for, I mean 2 when divided by 3, the remainder is 2, so server 2. R3 when you divide with 3, the 3 divided by 3 is 0, so server 0. R4 again can, when you divide with 3, the remainder is S1, right? So I mean 1 and so S1. So that is how we could potentially implement this. And there is also something called consistent hashing. I mean, this is one way to do this, but consistent hashing is more scalable, that you will be able to add more servers and remove servers and so on, right? At runtime. So this is just one key idea there to talk about. Yeah, hoping this
Sir,
makes
but
sense.
what if like one of the server does it has been designated that is down?
Yeah, correct. So in that case, uh, these so there is one problem that happens, like depends on your application if it is stateful or stateless, right? So if it is stateless, like in our case, think about this calculator wherein all we do is adding to bunch of numbers. It could have been routed to any server, right? So even if one of the servers goes down, you just bring up or have another server scaled up like S4 or so coming in, taking the place of S2 that was down, right? So it will, I mean, rehash these now based on how many servers are available, but the request itself is stateless, right? It could have been send this to any server and you still get the same result back, right? The application is the same code is running across various servers, so it is fine. But if it were to be stateful, wherein the user authentication or something has to be provided along with this API call, right? Like user related username, password, or some token needs to be provided. In that case, there will be some overhead because the server 2 would have cached, for example, the user 2 and user 4 information, which now the new server will not have, and so they may have to revalidate, right? Like re-login or resend those authentication tokens or so, right? So in those cases is where consistent hashing comes in, and it tries to solve this problem. But yeah, there is in this particular one, like using the same modulo operator to deal with this. This is the challenge that it depends again whether it is stateful or stateless calls. Right? So hoping that makes sense.
Yeah, okay, got it.
Yeah. So hello.
Yes, yes, Pradeep.
Yeah. So I would like to answer the Abhishek questions like how actually it works. Like in the cloud base, if you consider like AWS, so like if any node would get down, if it is part of load balancer, then we'll be having a feature like ELB health check, like auto healing part, where if any node get down, then the feature like the load balancer will not route the traffic to the faulty node. So the node will get out of the traffic, and meanwhile the ELB feature will spawn up a new server, new node, and in between the time, the only two node will serve the traffic, or the traffic will be routed only with these two nodes. And once the node, a third node get with healthy, then it will be part of the load balancer. It will be part of that auto-scaling group, which will be under the load balancer, and then on the base of path-based routing, so the round robin algorithm, the third node will also be healthy and will be the part of the traffic. So that what I experience.
Yes, Pradeep. Yeah, thank you so much for that detail.
Yeah,
So,
thanks, Phil.
so going forward, like the third part here as an example for non-functional requirements is reliability. So when do you say something is reliable is if it keeps producing what you expect, right? Basically, when you pass 2 and 3 to an ad program, you expect it to always give 5. It's not like today it gives 5 and tomorrow it gives 7 or so. So reliable systems are those that keep producing the same output for a given input. And so these are some of the non-functional requirements. Again, this is enhancing the experience of the users, because if it were not to be reliable, they'll simply switch to another application, right? Or if it is not available at all, like then they may switch to other uh, apps in general, right? So these are more about the user experience, but these are like the features that the product offers or the functional aspects of this. So once we have this, then these are something that uh, product managers try to write in something called business requirement specification or BRS, and then in the design phase, they may come up with, this is again LLD part wherein I talked about the signature of the method, right? This is the method signature where we say add is the function name. It will take two parameters like a and b, two arguments, and they're of floating type so that we support both decimal and integer addition here, and it will return a floating point here as the return type and so on, right? So there's the method signature and more close to code. Part of LLD, and eventually the developer writes this in something called an addition.py or so, where they define a method called add that returns this and returns a plus b, right? So this is just kept simple so that you focus more on the phases of SDLC and not the actual feature or the thing that is being developed here, right? So here, then this part is called source code, right? Which is the code uh, that the developers have now come up with, the Python file or Java file or whatever is the programming language used. Right? In case of front end, it may be the JavaScript, HTML, CSS files that they come up with. Hoping this is clear so far. So let's move forward. And then what are these test cases? As part of unit testing, the developer itself may write is they may create a file called addition_test, wherein they import this test module, import this original code addition file, and then call it for various values, right? Like they may call it for 2 comma 3, and then they expect that the code returns the value as 5. They may call -1 and 3 and expect that the code returns a value of 2. So usually these are called test cases, and these tests are done using some testing framework which provides these like assert statements here. So assert basically checks whether the output of add 2 comma 3 is same as the output, same as 5. In case it is, it passes this test case, else it fails, right? So that way unit tests could be developed and integrated into the same source code. And finally, all of this is pushed to version control system. So this is the first thing that we would learn as well in the next, I think in the next class also we'll get started on this. So we'll explore like various version control systems like distributed, centralized and distributed version control systems. Yeah, it's already 6:47. Let's take a break from 6:50 till maybe 5-minute break. I'm hoping is fine just for today, because we have been discussing several things and I want to cover more content today as planned. Okay, so then these Java files are compiled into .class files, and then they are packaged into a jar file called, jar itself is Java archive, right? J for Java and AR for archive. So it's a zip file of all these .class files. And then, you have all of these defined as part of continuous integration pipeline, and you give a cut to QA or testing team on this. If it is containerized, it will be a Docker image. If it is non-containerized, it will be a artifact like a jar or something like this. Yeah, so jar for Java archive, EAR for enterprise archive, var for web archive, and so on. And in case of Python, it is either an egg file or a wheel file or a image in case it's containerized and so on. So this is the typical process, and this example I'm hoping makes more sense. I mean, makes the concepts more concretized. That what actually mean? What do we mean by like functional requirements? What are non-functional? What is design? What is development code, and so on. Right? So this is that example. So next, I think what we'll discuss about are various process models. So the first one that was proposed in order to implement the software development lifecycle, right? So what are these process models? Basically, they are ways to implement these software development lifecycle. And the first model that was one of the earliest ones and straightforward for SDLC was proposed by Dr. Winston in, I mean, around 1970s. And it is very straightforward, and basically it falls, I mean, it's called waterfall model. So imagine this is each of these SDLC phases, the six that we discussed earlier, are arranged on a staircase, and each of these is like a step. If you were to pour water from here, this is how it would fall. Right? Like imagine all of this is like a staircase, and these are like steps. The first step is, I mean, the one that is highest is requirements, then design, then development. So this way, if you were to pour any water here, it would eventually flow like this, right? So water would fall like this, leading to this method name, right, called waterfall. So here, each of these phases are well defined, and what they say is only when the requirements part is done by the PMs is when the designers get started on design. Only when this is done, then the developers, then testing, then deployment, and then maintenance. Right. So basically, we are sequencing these out in this model. And this was one of the earlier proposals wherein they had like distinct endpoints and goals at each phase, and then it was all sequential that one happens after the other is done. Right, so we'll take a break for a quick 5-minute break now, and we'll talk about the pros and cons of this and which, I mean, some of the real world examples of this as well after the break. Right, and then we'll discuss more process models like this.
Okay, sir. Thank you.
Okay, I think there is a suggestion from Tanya or a request, and I think it's a valid one to yeah keep the advanced doubts and clarification for them towards the end so that the content that was planned for that particular contact session is covered, and we it doesn't disturb the flow. So yeah, it's a I think yeah I acknowledge and agree to this. So I would request yeah all of you to please try to follow this, and yeah thank you, Tanya, for calling out. Jyoti had another point. Okay. Yeah, got it, Jyoti. So I'll yeah, when we get to the coding part, I think we'll always start from scratch. Like so far, I think uh, whatever concepts we have discussed, I tried to keep it like first the theory part, like here, and then showcase a few examples of this. So I'm hoping that is fine, or I can go in more depth as well. I mean, from scratch as well. I'm hoping, I mean, these examples are clear. Please confirm, Jyoti. I mean, is it about the lecture content or is it about the students who are not? Okay, not coding background. Okay, maybe question to you, Jyoti. So far, like whatever we have discussed, is it fine? Like you're able to follow these? You can unmute yourself, Jyoti, if you're around.
So this is the same request like the Tanya, as Tanya was, I mean, Tanya already conveyed. So I mean, few students which were, I mean, they are not from the coding background, and students who are asking too advanced doubts. So actually, it's creating a lot of, I mean, issues in understanding the concepts. So this is the main concern.
Okay, yeah, got it, Jyoti. So yeah, I think yeah, it's a request to everyone, and yeah, like if I see that it's a advanced concept, maybe I will try to push that for the break time so that we discuss those during the break time. And yeah, thank you for calling out. And
Yeah,
yeah, my
thank you,
question
sir.
was
Thank
more
you.
on whatever content I'm trying to cover is I'm hoping that is from scratch and is clear. And I mean,
Yes,
my
yes,
point
yes,
is,
yes. It's
yeah, I
clear.
want to even
Yeah.
target and ensure like people from non-coding background as well are able to follow. So yeah, in that lines, I was asking the question.
Yes, sir. Thank you. Yeah.
Thank you.
Sir, one question on EC1, can I ask?
Yes, Devi Prasad. I think yeah,
Okay.
you are. Yeah, sorry. Before that, yeah, I just wanted to acknowledge the yeah point Devi Prasad had over chat. So I think what Tanya and Jyoti are also pointing out is all those advanced ones that are not related to the current content being discussed, we could probably push them to the break time. But yeah, anything related to that slide being discussed, yeah, definitely will take up immediately and discuss. Yes, Mohnish, please go on.
Yes, sir. So, for EC1, will there be only quizzes and assignment, or will there be any project work?
So for yeah, as part of EC1, I think we'll have like two quizzes and one assignment. About the
Okay.
lab sheets, I'm yet to discuss with the team, like based on the lab environment. Once it is made available, like I have sent out a request, but yeah, soon we should get the confirmation, and yeah, I'll also make an announcement that the lab environment is available. So yeah, we'll discuss about the lab assignment part at that time. But yeah, from EC1 point of view, I think we'll at least have like two quizzes and one assignment, if not others.
Okay, and that will be individual assignment.
Correct. Yeah, everything would be individual.
Individual. Okay, okay. Thank you.
Okay, welcome. So I think yeah, it's 6:56. We'll continue. Hoping yeah, whoever have taken that break are back. So let's continue. Yeah. So does anyone want to quickly confirm? Like you can react in the teams as well that you're all back, just to ensure. Yeah. All right. Okay. So we discussed about waterfall, and I think this explanation is something I have done already earlier as part of the discussion. So what we are looking at here is as part of each phase of the SDLC, what is the expected outcome, right? So outcome of the phase one, which is requirement gathering, is project managers participate them in meetings with the client to gather the requirements, and the outcome is a BRS or business requirement specification. And then the business analysts convert these business requirements in conjunction with the uh, subject matter experts, the architects, and so on into something called TRS, which is technical requirements specification, sometimes also called SRS for software requirement specification. Right? Because whatever they come up with technically is at the end we develop software for it. So it's a software requirement specification as well. Right? So these are the outcomes. And then as part of the development, whatever the developers come up with is the source code. It's also loosely called like a document, but it's actually the code files that they come up with. It's a document with various extensions like .py for Python, .java for Java, and so on. And then, as part of testing, ideally, what we expect is defect-free product and certified artifact. But you may have like some open bugs, and in which case we may have to reiterate or do the development again for it, right? But ideal outcome at the end of this phase is whatever we expect to be delivered to the customer are defect-free and are certified, right? I mean, QA or testing team would only certify if the all the test cases pass and there are no defects found in that product. Then we have the deployment phase, wherein the software is fully tested by now. It is defect free, ready to be deployed, and generally it is promoted first to staging environment. And once the manager and the customer give a go ahead, or the consents of respective stakeholders are taken into consideration, then I mean, all the approvals are taken, and then the code is promoted from that staging to production. Right, and even if the software is deployed, that doesn't end the uh, responsibilities of DevOps. They still have to monitor it, maintain it, and so on, like we discussed. Right? So here the outcome is a usable product available to the end user. And finally, for maintenance, it's you keep identifying issues and keep deploying new software, new versions of it, and so on. Right? And if your issue is of high priority and huge impact may be there, you may have to roll out to a previous stable version or give a fix for it soon in the form of hard fix or patch or so. All right. So when to use waterfall model is of more interest to us, which is if at all the requirements are clearly defined at the beginning, that is the key reason why you would want to go with for waterfall model, right? Which means whatever requirements we had, like for example, the calculator application case, the requirements were very clear and it is freezed, right? That you want to have add, subtract, multiply and divide as the functions. There are no new requirements that come in when development is being done or testing is being done, right? So it is very well defined and freezed at the beginning itself so that the respective architects can convert it into a high level uh, specific design specification, and then the designers to LLD, low level design, followed by developers developing it, testing it, and so on, right? So everyone is clearly aware of what were the requirements, and based on that they write the design, and based on this design they do the development, right? So, and even client for that matter doesn't want to involve more in the development and only reviews the output that is available in the staging environment for them. And they also do not have any changing requirement, right? Like not even the product manager and the client as well, right? They are also just waiting for this to happen. And typically this cycle that was followed in the earlier, I mean, initial years, like maybe 10, 15 years before, I guess, is where this time frame wise it takes usually 6 months to release one particular product, right? One version of that product. The reason it takes 6 months is all of this is sequential, and requirements itself may take 1 or 2 months in it, and then designs for a month, development for a month, testing, and so on, right? So that way it usually becomes like 6 month to 1 year release. And most products back then had like yearly releases, right? Most common well-known example is Microsoft uh, rolling out operating system Windows. They had like Windows based on the year of is where they had various OS versions. Like you had like Microsoft Windows 2003, 2004, 2007, 8, and so on, right? Because those were yearly releases, and teams generally used to take a year to work on all of these. And usually it was the waterfall model back then that was followed, right? And the working technology is also clearly understandable. It is a linear and sequential approach where each phase must be done before the next one. Yes, Saurabh.
Uh, Sai, so I had a quick question, mainly on like, for example, let's say during the testing phase, what if there are few bugs detected, or what if there were a few test cases which did not go through? So in that case, shouldn't there be a development again to fix those bugs before it is rolled into the deployment?
Yeah, so that is correct. And usually when we talk about this waterfall model, we are talking more about the end goal or the requirements that we had started with. Uh, and bugs usually occur at various levels, right? So maybe the designer didn't correctly design for what were the requirements, right? So then it is a design bug. If the developer didn't implement what was designed correctly, then it's a software bug, right? And if the tester had a wrong scenario because of which it failed, then it's a test case bug. And let's say the developer, along with the source code, they typically write the documentation as well to follow. And if let's say there is some issue or error in the document which is misleading for the tester to test it correctly, then it's a documentation bug, right? So there are various stages and various types of bugs we may have. This and so the respective stages here would be then repeated, but the key thing to notice here is it is all sequential. That let's say, let's talk about the worst thing that could happen in this model is the client itself comes back and says, after let's say 2 months of the process, they come back and say, we want along with divide, we also want to have modulo feature, right? So that was never planned in the first place, never designed, never developed, and so on, right? So which means we have to go back all the way till here and then pour water. Else, if let's say it was a design bug, you start pouring water from here, right? And else, if it were to be a development bug like software one we discussed, you start pouring it from here. So the location at which you restart this cycle may differ based on the type of bug, but essentially the key highlight here is it's all sequential, and only, I mean, one thing happens, only then the second thing starts after this, right? So that's what we are trying to highlight here in this diagram, right? But yeah, you're right that based on the type of bug, I'm hoping this is clear that you restart at that particular step.
Yeah, thank you.
Okay, so what are the disadvantages of waterfall model? So as we discussed, there is no feedback path until the end of the project, or measuring the progress for each stage really becomes difficult, because at the end of design, how do you know that the design document meets all the requirements or not? Because only during the testing phase is when you know whether the code that is developed is actually meeting the requirements or not, right? So there are various issues here in the feedback mechanism and checking the progress part. But the key reason why this model uh, was, I mean, is not being followed these days, and the key drawback of this model is it's in flexibility to changing requirements, right? So what we mean by this is the requirements, as we know, is generally not freezed. It keeps changing because that is the real world and reality, right? So either the product managers come up with, let's say, they see that the competitor is releasing some key feature that may, differentiate or have more people buy that product over the current product being developed, then they may come up with new requirements to be accommodated at any point in time, right? So which means the requirements are no longer freezed, and the same thing may happen with the client as well. Even after they make the service level agreement initially, they may come up with a few more to see if we can accommodate them as well, right? So because they are the ones who are at the end paying us, and so we are bound to support them. And uh, so the changing requirements is the key disadvantage, wherein waterfall model is very rigid and it cannot accommodate those, right? Which means we have to repeat the whole cycle again only if there were to be any changing requirements, right? So that's one. And second is there is no intermediate delivery, meaning till that deployment point, the end user cannot really see the product, right? They have to wait for all of these to happen. And usually it's like they wait for 6 months or so to see the application, right? So that is a long waiting time that people thought, and probably like it's better we have some intermediate deliverable rather than to wait till the end, right? So these were some of the reasons or disadvantages of this, right? And that is where the next model has become popular, which is okay, which is V model. So we'll get to this V model, but before that, let's look at a real world example. So IBM, in when, I mean, it's very old time now. The example that we are referring to, when they were developing like mainframe operating systems like OS 360 or so, they were following this waterfall model, and because the requirements itself were clearly defined earlier, they had a structured development process of this, and extensive documentation was done at each phase, right? Like after requirements phase, we discussed it is BRS or business requirement specification. Then designers write the technical requirement specification and so on, right? So it's extensively documented throughout this, and the requirements were also clear. But the cons were they whatever software they, I mean the OS they tried to develop, at the same time the hardware also kept on evolving, right? Let's say in that 6 month or 1 year time frame, whatever software OS operating system related software they were writing and developing, that may not be compatible with the latest hardware, or there were some issues with respect to compatibility of that with the evaluation of hardware in parallel, right? So they had to always do this integration testing and realize that maybe that software had some issues, or they may have to replan and so on, right? So the even the design flaws, like something wrong in the design, was only exposed during the testing phase, which is like very delayed and so on, right? So these are some, I think this, so Fred Brooks, project lead from IBM, actually wrote about these challenges specifically. He called it the mythical man month, wherein, I mean, why he talks about why waterfall doesn't work well for complex projects, right? So that is one example for this. I'm hoping this is clear. So any questions, anyone on this, please let me know. But yeah, we'll talk next about V model that tries to address at least some of these challenges, right? So we'll talk about how that addresses next. Right, so let's move forward. So what V model brings to the table is this same waterfall is like this only. The left side, if you were to see, you still have the same waterfall model. Additionally, they have come up with something called test phase, or also called validation phase. So V actually stands for two V's here. Uh, and this whole model, if you see, is in this form of V shape, right? With all these stages in place. So that is how this name for this model has come in. And it stands for validation and verification. So verification is same as the waterfall model that we had earlier. But what changes here is essentially ability to test each phase step by step. Right? So what we mean by this is having parallel testing done or validation done for each of the phases we have, right? So this table showcases, for example, when developers, I mean, in the development cycle, let's say product managers are working on the requirements, the testers then can parallelly work on what is the acceptance criteria and do the test case planning there, right? So they can come up with documents of defining what is the acceptance criteria, because in dev phase they would say as a user I should be able to add two numbers. Here they can say it's accepted that when two numbers are given as input, they could be positive numbers, negative numbers, mix of them, and all of these give out the desired result is an acceptance criteria that they can come up with in parallel, right? So similarly for HLD or high level design, they may come up with what is the system test planning, like what integration tests they have to do, that this backend server should talk to this database and there should be seamless integration between these two. So they can come up with test cases for that, and for low level design as well accordingly. Right. So basically at each phase you see here, for requirements it's acceptance, for system design it's system test, architecture part integration test, and so on. They are trying to progress and not wait for the development to be done, right? During each phase itself, testing team is also parallelly working on this. So that way it is basically an extension of waterfall model introduced in 1980s. It is also linear because both of these converge at the point where code is given, right? Only when code is given out is where they can execute these. Only the planning and uh, the test case preparation is done in parallel, but execution can only be done once the development team gives the code, right? So they are joined with the coding phase here. Hoping this is clear. So This is just trying to, taking one step forward of validation phase, introducing validation stages for each verification phase we had otherwise in waterfall model. Right? Maybe let's look at Intel as an example here, right, which followed this for developing firmware and microprocessor drivers. So the pros they had in following this was strict validation and verification was being done. So this integration phase wherein they integrate hardware and software, right? So was being planned well before, and by the time they get code, they were able to execute these and ensure these are like compliant, the hardware and the software part. They could catch early defects because of the parallel testing they have at each stage, and that ensured like high quality output is the pros. But coming to the con, I think Intel's Pentium floating point bug is very popular. Like it was a real world validation step that got missed out, right? Wherein division calculations, uh, the algorithm itself, it was producing incorrect results precision wise was something that was found by a professor, but not by the Intel team itself, right? So this just exposes the lack of the firm validation phases they might have missed out in this case, but this is just to call out one of those cons like that happened here. And the final one is rigid structure. Actually, in fixing this, once the bug was found, they had to recall this version and they had to spend a lot of time, and it caused damage to the reputation and others because of this floating point bug. So, it's not like we just have these phases defined. Those have to be concrete as well, and they should have like proper uh, test cases in place, which are real world, is the key takeaway here, right? So, this is just one example on this slides. Okay, hoping this is clear. We can move forward. So far we looked at.
Sir, one
Yes,
question.
Ajit.
One
Yes, yes,
question on the previous slide.
yes, yes, please.
You're saying the benefit pros of this model is got defect in early stages.
Yes, yes.
But if you see like a requirement design, we are designing the acceptance test,
Yeah,
but until the product is not ready, how because product is going to be ready in a coding stage.
correct. Yes.
How we can write the test cases, but testing is going to done at the end.
Yeah, yeah. So that is with respect to the actual software. The uh, technical source code that is being written. But for example, the requirements itself, they can validate. Its requirements is just a document, right? So that way they
Yes.
can easily have test cases and validate at this phase. Whereas that was missing in this case. Like there was no one sitting and verifying whether the requirements were meeting, or validation of this requirements was not there here, right? So that's something that is added here. And
But
yeah, like, yeah,
integration in the case of integration test, we need
correct,
the product to do the integration testing. But
correct,
product is going to ready in the down,
yeah,
means we can do the acceptance testing parallelly to the requirement.
yeah,
Even system test also, I am not sure how, until and unless
okay.
product is not ready, we can't do the system testing.
Yes, yes, agree. So I think, yeah, let me rephrase my statement about this. So yeah, I got your doubt, and yeah, let me try to clarify here. So what is being done in parallel is the um, you know writing those test cases and putting the effort in writing those tests is what is being done in parallel. But the flow wise, if you see, there is a small arrow here that says like it goes like this only, that
Yes.
once the code is available only we will be able to unit test or integration test and so on.
Yes.
But earlier, unless and until the requirements were done and the designs were done, the testing team was not actually writing any test cases or not even planning anything here, right? They were
Yeah.
all waiting for all of this to happen. So
Yes.
I think that is what we are trying to do it in parallel here, wherein we are
Yes.
yeah, at the each stage. And also each stage here was not being validated. It was only the development source code that was validated here via functional test cases. Whereas here we are also trying to validate whether the requirements or the system integration tests and others are in place. Right? So it's more robust and more focused on having the validation done for each stage, and at the same time put in effort in parallel and not wait for this. So slowly from this being sequential, we are trying to move more and more towards having some things done in parallel and make it like a uh, do better at this. I think similar concept is also used in instruction fetch, decode. As you know, like processors have this instruction life cycle, wherein each instruction there are like six phases, I guess, which are like fetching the instruction, decoding the instruction, and all that. And there they refer to this concept, the same thing like V model. They call it like pipelining, right? So pipelining is a concept there, wherein when one instruction is being fetched and it's being decoded, the other instruction in parallel can be fetched, right? So
Yes.
they just try to optimize there, that some things could go in parallel. But again, based on the outcome of the first instruction, let's say if it's an if-else statement, they would have fetched the if part, but the runtime says else part has to be executed, and so there may be some loss of instructions there, right? Like it may have to repeat certain things, and it may not be optimal always, but at least attempt wise, we are trying to do like branch prediction and get the right instruction prior and save some time there, right? So we are trying to do some things in parallel is the key idea, and V model is an attempt towards that.
Yes. Got it. Thank you, sir.
Yeah, thank you for the question. All right, so next one we have is people then realize that while this is well established, the software development lifecycle and the waterfall model, having intermediate deliverable is the key, because we can't, the time to market for a particular product has to be very low. Only then they can essentially compete well with other products, right? Because usually, like for example, WhatsApp, I think was launched way before other messengers, and so it became because it you always have that advantage of first come first. First comers are the ones who capture the market a lot, and market capture is the key, right, for having the products well established and well received, to be well received by the customers, right? So what they have realized is, let's actually have a deliverable more frequent enough than this 6 months or 1 year long time frame that we are trying to have. And that is where they try to come up with small life cycles of the same waterfall model. Like if you see, this is also waterfall only, but it's just that it's a very small one, meaning instead of having like, let's say 20 requirements, you just bring it down to one or two requirements and then do the whole cycle, right? And repeat this any number of times you need. So those are called iterations. And how does this help is, right now you're focusing on only few of those requirements. So even if the requirements change, there is high probability that those were not something that you picked up, or those were the other set that you were parking for the next iteration. And so you can welcome or absorb that change, right? So let's say we are working on 3 out of 20 requirements. The remaining 17, even if you change after this iteration is done, it is fine for us to take them, right? So that's one idea. And within these 3 requirements as well, even if they were to change, in the iteration 2, you may redesign these 3 and then take another iteration to fix these 3. Now that we are reducing the time frame, like these iterations itself are meant to be very short, maybe like 2 weeks or 3 weeks time frame, not beyond that. And so you can now reiterate on the earlier requirements or on the new ones as well. Right? So that's the key idea and shift here. And the feedback from each iteration is taken, and the next cycle or iteration is improved upon based on that. Right? So that is what is iterative model highlighting here. And this now becomes non-linear, because earlier you never had to, this whole cycle you are kind of repeating again and again, so it's like in loops, right? So it's in iterations, so it's kind of non-linear, right? Earlier you had like a waterfall, here you are actually going back, right? The water is being pumped up again, right? So that way it's kind of non-linear in nature. There's also allowing for incremental improvement for those software being developed. Yes, sir.
Sai, so in this model, is it that it is modular in nature and there is no fixed flow as such, or is there a fixed flow?
Flow is still fixed, like you see this flow of the phases here. So you still go through this same waterfall model type. It's just that now the whole time that it takes in doing all of this is reduced because you reduce the number of requirements that you are planning for this iteration. Instead of working on 20 requirements, you are asked to work on only one or two of them, right? So, or three of
Oh,
them, like we discussed earlier. So, because you're reducing the effective time for this cycle, that is where you now have more chance to either accommodate like changing requirements as well as take the feedback from this and improve upon it in iterations, right? And at the end of this, you do have a deliverable, an intermediate deliverable as well, because those 2 to 3 features are something that the customer can then use as well, right? For example, in our calculator example, maybe add and subtract we are able to take up and implement. So they will roll out that to the production, and they'll at least use add and subtract functionality before we work on multiply and divide, right? I'm just giving an example again, which is very new, but you can extrapolate this to or apply this in to any of those real world projects that you are working on, right? Like same thing could be done for like e-commerce website like Amazon, wherein you roll out bare minimum features that are needed. It's also called MVP or minimum viable product related features, and then you work on other things that in parallel, or I mean while the customer is using them, right? So that's the idea. Does that make sense, sort of, and what
yeah,
are
it,
those?
it does. It does. Thank you.
Okay. Yes, Yuvraj.
Yeah, what is the intent of having that arrow from iteration 2 towards iteration 1?
Okay, so it is just showing that the feedback from that iteration is used to improve this cycle. Like basically, you end up in design phase because as part of your review is when you know that something is wrong with design. Else, as part of review, you may know that you may have to go back to some other phase, right? Maybe the development is wrong is iteration 3, right? I should have had here development instead of design. So that way, based on that review only, you know whether it has to be redesigned or redeveloped, right? Something like that. That's the significance.
Right. Then in that case, arrow should have been from review towards design phase, right? Not the other way around.
Yeah, yeah. I mean, the idea here is like in general, the iteration 2 is looking up to iteration 1 and improving upon this. And so the arrow is like this, right? Like, it's like inheritance diagram that you draw for class
Oh,
diagram. I mean, if you're
okay.
familiar with
Hmm.
UML, you always say the child class looks up to the parents class, right? Ideally, it should have
Hmm.
been like parent attributes are reused in child. So there also it should have been like
Hmm.
from parent to child. But we say child is
Hmm.
looking up to the parent and using those attributes, right? So same thing.
Okay, okay. Okay, so iteration 2 is going to pick up from where iteration 1 left. That's the
Correct,
idea.
correct.
So it is
Yes,
going to refer
and
to iteration 1 outcome.
correct, correct. Yeah, and
Okay.
I mean outcomes, and also accordingly know like which of these should be done. Let's say on a happy path, 3 out of 20 are fine. Then it will pick up the remaining 17. I mean maybe two more from that 17 pool, right? Because it knows now that first iteration successfully implemented 3 out of 20. So let's pick some two more from the other 17. So it depends
Agreed.
basically
Okay.
on yeah. Yeah,
Yeah.
it's like a loop, and that's why these are called like iterations in that loop. Yes, Tanya, that is correct. Right. So this model, that is the reason it's called iterative model, that you, because in a loop you run various iterations, right? Like in a for loop, you basically loop through an array of elements, for example, and each iteration you print one element at a time, right? So something like that.
Okay. Thanks.
Okay. There was one more who had raised hand, but yeah. All right, let's move forward. So similar to iterative model is in 1986 time frame is when from Barry spiral model has been introduced. It is also non-linear, and the name again comes from like how we have this Martin coil or so, that you would see that if you lit the, I mean if you ignite the coil from one end, I mean usually in this case, you have to ignite it from the center. It would come out and burn like this, right? So that is this spiral model about. And what spiral model brings to the table is risk analysis. Uh, in general, it is called like SWOT analysis. You have your strengths, weaknesses, opportunities, threats, and so on. Basically all of these. I mean, uh, business analysts, or I think the ones from management side, do a lot of this risk analysis uh, along with the team, the product development team. So the key idea here is to bring that as a dimension to look at and include it as part of the software development lifecycle. Right, so it integrates with the iterative model approach, but each iteration that we are going, we are going through here, right? Each curve here, each circle here kind of that we are going through is visiting all of these: risk analysis, product development, evaluation, and planning. So you're just going through all of these, and that is how this is called a spiral model. It's extension of that iterative model, just to have this risk analysis or risk driven approach here. Right. So concrete example again on this would may explain this model a bit more better. So example is, if you are building a real-time fraud detection system for a global bank, tech components wise, you may say like, because it's fraud detection, you need some machine learning algorithm to run, which means you need like huge volumes of data for training it well, right? So which means it may be big data, either volume wise, variety wise, however it is characterized. And then you run your machine learning pipeline against this data. Uh, but then the other component, which is business risk here, is risk of the software that you're developing being non-compliant with regulatory standards, right? So regulatory compliance is coming from the risk analysis point of view. For example, GDPR from European Union, which says, GDPR stands for General Data Protection Regulation, which means organizations are not supposed to retain the data of users for more than, let's say, 5 years or 10 years after they stop using that service, right? So I'll give a concrete example to make this GDPR thing more easy to consume. Is, let's say we are using our mobile and we are subscribed to, maybe we are using Airtel initially as a SIM card provider, and then we switch to Jio. So after 5 years or 10 years after we switch from Airtel, Airtel is supposed to not maintain our personally identified information like email or address or other things uh, anymore, because we no longer are using that service and we have shifted to Jio, right? So they either uh, delete that record altogether, the account details that they had for us with Airtel, or they obfuscate as in they mask the data so that the employees of Airtel do not get to see our data or private personal information, and so on, right? So those are some regulations and standards that were set by European Union in the form of GDPR, and they said if any product doesn't implement this, they won't allow that product to be run in their in the Europe region, right? So that's where it started, and it started to, all the products were then had to go through this GDPR compliance and so on. If, let's say, this was not planned before, like only iterative model was done, the software would have been ready, but it wouldn't have been meeting these regulatory compliances, right? So that is where this risk analysis, at each phase, they try to analyze and see that it is meeting those.
So that is the combination of iterative model plus waterfall model plus risk management spiral
Correct,
model.
correct, yes. Actually,
So
iterative
that
model
means,
is, yeah,
yeah.
sorry. Iterative model is
So
already having the waterfall model here, because this is the phase in that, but it's just confining the waterfall as an iteration, right? So that's the iterative model, which is repeating or repeating the waterfall model many times, right? And spiral model is adding that risk analysis part to it
So,
dimension.
according to the diagram in a spiral model, that means it's shaped like a spiral, right?
Yeah,
So, in a spiral, every loop of the spiral represents is one
correct. Yes,
iteration.
yes, yes.
As the spiral moves outward, then the software becomes more complete.
Correct.
Is
Yes,
this so?
yes, yes. So
Okay.
the example of that coil, if you were to burn it here, it would eventually burn like this and come out, right? I mean, it would end here. So same route we would do, and at each round of that coil, it goes through all these phases is the idea. Yes.
Okay, thank you, sir.
Okay, so continuing on that same example, maybe in the cycle one, we can do initial prototyping and risk assessment, like identify uh, what techniques we would use to anonymize the data or do data masking, right? And then second, we may address those and expand the scope for making more components compliant. In the third phase, we may integrate machine learning layer. Again, there also we need to see if it is fair. These days, there's something called fact based machine learning development, which is fairness, accountability. Um, I think, yeah, I don't completely remember that acronym, but FACT, FACCT stands for fairness. I think A for accountability, C for I think compliance and other things, right? So that basically means at each stage, all the components that you're developing have to be fair. The model that you're developing has to be accountable for whatever output it generates and so on, and meet the regulatory compliance. And finally, towards the fourth cycle, the fourth coil here, you may get like scalable, failover, compliance checked product. So that's just one example to showcase this. And I think Microsoft has followed this for developing Windows Vista. Right, so it allows flexibility and reiterating the risk management and so on. Uh, yeah, and I think, I mean, cons wise, I just had to list a few here just because we would next go to the other model. To be frank, like this model itself is actually having many dimensions to this, right? So only things that were cons here were Microsoft kept adding more features in that cycle, delaying the release by more time, right? For that Windows Vista, I think you all know like how much time it took to finally be available. So frequent risk analysis added that overhead is the major con that is highlighted here, but it's that call and trade-off that we have, right? Like whether you want to test, I mean, keep checking for the compliance at every iteration, or what's the trade-off there, right? Like it may, as we know, like as we understand, it will add an overhead because not just product development or software development, you are actually checking the compliance against that at each cycle. So that was what was adding to the delay here and was called out as a con. But otherwise, yeah, this is already a robust mechanism to do software development. Okay, so yeah, if this is clear, maybe let's move forward. So then comes agile process models. So here is where taking the same spiral model and iterative model to the next level, wherein agile actually is a broader term and it's a group of software development methodologies that were documented. There is also something called Agile Manifesto, which we'll discuss next. So in 2001 timeframe is when a bunch of people came in and started to propose this methodology, and it is a set of practices. And they wanted to take best of all the models so far they had, wherein they want to make it lightweight. That, I mean, that iterative model was making it lightweight, right? And I mean, one or two requirements only we were taking up in a iteration and working on. At the same time, wanted to make it more flexible to changing requirements than waterfall and others. So it is basically an iterative and incremental approach that again emphasizes on flexibility, customer collaboration, and responding to changing requirements. Right. So it's a set of practices that were documented, focusing on making the whole software development cycle iterative enough, incremental approach to taking the changing requirements and customer feedback and so on and incorporating them. Right. So it breaks down the project into small manageable units. They are usually called sprints. Sprint can usually be like 2 to 3 week timeline wise. It can span 2 to 3 weeks. So that same iteration, we are now making it more concrete and calling it like a sprint and have a timeline associated with it and so on. And it delivers like working software frequently. At the end of each sprint, you have that intermediate deliverable ready to be uh, shipped to the customers. Right. So this is about agile, and let's look at the manifesto, which again it is something that they have. This is the same thing that they would have quoted in that manifesto that I'm trying to take here. So they are saying like we are uncovering better ways of developing software by doing it and helping others do it. Right. So I mean, these are like just statements wherein they try to emphasize that along with the work, they try to get some value added to it. So here is where the key things change in this. The key points here to note are individuals and their interactions are given more preference over processes and tools, right? And even over the comprehensive documentation. So that is where we need to have like daily meetings. Earlier, we used to meet, in the meetings of the development team were like monthly or even like once in 2 months or so, when the uh, model was like waterfall model where like they had like 6 months or 1 year of development. And that was fine there because there was comprehensive documentation. Lot of time was spent on the by the product managers to write the requirements clearly, by the designers to write the design clearly, and extensive documentation was there throughout. Whereas what Agile says is, in order to cut short the software development lifecycle and to make it short and iterative enough, let's give more focus to the individual and the interaction among the individuals, more priority over the extensive documentation, right? So that is where decisions that are, maybe the design change or whatever are taken more frequently in the daily meetings. These are called like daily stand-ups and other things. There are like some of the ceremonies of this whole agile development will which we'll get to, but the importance of meeting everyday basis and individuals speaking up and talking to each other is given more priority, because now they don't want individuals to waste too much time in having extensive documentation, right? Because what they have realized is anyways the requirements are bound to change, so what is the point in having the document having the proper documentation for those requirements in the first place, right? Because those anyways keep changing. You keep updating the design, updating the requirements and so on. So rather than that, let's focus more on collaboration, and uh, the documents now do not need to speak for themselves. The individuals and their interactions are the ones that get the work done, right? So there is a shift uh, primarily in this aspect, right? I'm hoping it makes sense. Please confirm or react. And yeah, okay, we are almost towards the end. Like we just have 10 minutes, but I just want to cover this agile manifesto and certain things about agile in this class. Please confirm if it makes sense. Okay. So Jyoti has responded. Thank you. And others as well. I'm hoping this is fine. The second concept here is customer collaboration is more rather given emphasis and priority over contract negotiation. So earlier, what used to happen is we used to stick to whatever has been made as part of the SLA or service level agreement, whatever has been negotiated. And if customer comes back and asks for something else or changes the requirement or asks for additional features, we would strictly say like we never committed had it in the original contract, so we'll not be able to accommodate this. Whereas here, Agile says we want to be collaborating more with the customer and accept and embrace the changing requirements, because now we are making the whole software development cycle lightweight, having the iterations, and so even if requirements do change, we will be able to accommodate, right? So that way, this is given more focus. Right. So while there is value on the items on the right, like having proper sticking to the contract negotiated or sticking to the documentation, we want to value the items on the left more, and that's the that's why there is a lot of change in the way we look at things after agile and before agile. Like how we have BC and AD, I guess this is, I mean, before Christ and after Christ, it's like before agile and after agile, the models and software processing, I mean, development life cycle has changed in the way we look at it. All right, so what are the key principles of Agile is customer satisfaction through early and continuous delivery of the valuable software, right? Software will be valuable if it is tested properly and there are no bugs in it. And secondly, continuously you deliver that software and it is early, right? Because you now don't work on all 20 requirements, you just focus on 2 or 3 and keep rolling out the software to the customer, right? So that those at least they can get started to use. Then we have welcoming the changing requirements. Third is delivering the software frequently. Fourth is daily cooperation between the business people and the developers. So in the form of daily meetings. And then motivated individual and self-organizing teams are given more emphasis here. And face-to-face conversation is best form of communication, not via documents, right? So one person to another, they should not communicate via those documents. They should communicate face-to-face is the emphasis here. So keep those documents lightweight and talk more, interact more, and get the thing rolled out. And that's given more focus here. All right. So yeah, with agile model, I think Windows 10 onwards and later, Microsoft started to roll out the versions of Windows more frequently. As all of you know, like after Windows 10, I mean, even though we had Windows 11 as well, Microsoft announced back then that that would be the last version of Windows because they then would be rolling out these updates more frequently for free of cost, right? Like all the updates that we receive for Windows 11, for example, like bi-weekly or weekly releases of Microsoft. Usually, I think they do it on Tuesdays or so as a timeline. So those that we keep getting, we keep getting the newer version of it, and it comes to us in the form of an update. And whereas previously we had to purchase another, these softwares were sold in the form of CD. So if you had Windows 7, if you wanted to use Windows 8, you had to get another CD, I mean, another license, another purchase, and so on. Whereas now it's the same version, you keep rolling out the versions of it more frequently, right? So that's the shift. And even for Azure, whatever practices they had, like all of these cloud service offerings from Microsoft, the latest versions of those are available uh, at more frequency than earlier, right? So that's the continuous integration. And I mean, they have a CI/CD pipeline for Windows as a service, right? And basically it was better adaptable. Only con was the mindset of those people and Microsoft engineers initially, right? Because they were so used to waterfall that they found it hard to adapt to agile, wherein at end of every 2 weeks you have to release the product. So it was, I mean, the shift in the mindset initially is the only con. But otherwise, like long term stability point of view, this I mean, the other concern is, I mean, at long term they did adapt this. Most organizations are now following agile methodologies. And the second con to just call out is long term stability, because now they, given you are releasing it more frequently, you are bound to more bugs as well, but you will eventually fix them in the next cycle, right? So while those that were slowly developed, like spending a year on that, could have been more stable with respect to code. But this, because it's more frequent, you'll eventually uh, cover up for whatever bugs you may release more frequently as well. Yes, Devi Prasad. Yeah, please go. Yeah, Devi Prasad, you can maybe ask your question if you.
Sorry, can we say DevOps is the extended version of Agile or matured version of Agile? Is it the right way of putting things?
So DevOps, I think, is basically trying to bring this whole agile methodology into reality, wherein they are applying these to the product being developed, right? So DevOps is actually essentially uh, preparing or implementing this in the form of that automation scripts, CI/CD pipelines, and other things that they develop. So they are taking these concepts and applying this to a real world product or project being worked on. And the aim of DevOps, like we discussed, I think in the first session and briefly today as well, is to shorten this cycle and make it more automated so that it is scalable and repeatable, right? So that is the end goal of DevOps, to deliver continuously valuable software to the customers, right? And in doing so, they can come up with automation scripts, tools, and mechanism to have this. So they are basically implementing this for the product or project taken.
Okay, maybe increasing the release frequency by,
Yes.
yeah. Okay.
Yeah, by automating the pipelines and also having like frequent releases being planned, because you cut short on the requirements now for a given sprint or iteration.
Okay.
Okay. All right. So next thing we have is TDD, FTD, and BDD. But I think we just have 2 more minutes left. So let's just discuss about TDD in today's class, and we'll talk about others in the next class. So talking about TDD, it is test-driven development. So T stands for test, D for driven, and another D for development. It's a process where you write the test cases way before you write the actual code, right? So let's it is basically focusing on having the test case, driving the development based on the test cases you write to ensure you get high code quality and reduce the bugs, right? So the cycle of TDD looks something like this: that you write a test for a new feature, run the test, and it will fail because the feature is not yet there. And then you write the minimal code to pass this test. You test again and see that it passes, and then you optimize that code, right? Initially the focus is on correctness, then you optimize it to improve the performance of it, right? So first uh, way is to get it correct and ensure the test case passes. Then you refactor the code to improve the performance, right? So you may have a O of n square algorithm for sorting, bubble sort or so, but eventually you'll get to merge sort or others where it is O of n log n time frame, right? So you can improve it at a later point, but having it correct, writing correct code is the key thing that uh, this TDD focuses more on. So let's look at a specific feature and example. Imagine we are again that same calculator example of implementing addition of two numbers. Firstly, you will write these test cases, right? That you test add with 2, 3, you expect 5, 2 minus 3, you expect minus 1. But that will fail because the add function itself was not defined or not there yet. Then you implement the feature of add addition, run it again, that it passes. Then you may want to refactor if necessary the code to make it more optimized, right? This is the cycle of this test driven development. Yes, Yuvraj.
Yeah, my question is on Agile. Can you just go to cons of Agile?
Yes. Yeah, sure. Which of these slides? Is this
Yeah,
one?
yeah.
Okay.
The next one, I think.
Okay.
Okay, over here. Now, one of the things which I've noted with Agile is, and as you talked about, is we are giving less importance to the documents and we are ensuring that
Correct.
people
Yeah.
talk to each other.
Yeah.
Now, there are certain things wherein there is no documentation at all. Like, there are
Yeah.
situations wherein people are not writing documentation at all.
Mhm.
Writing extensive documentation is a problem. Yes, it takes time, but having
Yeah.
no document is another
Is also a
tunnel, which
problem. Yes. Yes. Agree. Yes.
that's also a problem, right?
Yes, yes. So there is a trade-off. Basically, the trade-off that we are trying to do here is to cut short on time. You're not focusing too much on the documentation because writing extensive documentation takes time, whereas not having documentation at all is not maintainable, right? So the product
Right.
itself will not be maintainable because if those folks who are working on the that
Exactly.
feature,
Exactly. Mm.
may leave the company soon or so, then the freshers who join will not be able to
Correct.
even understand what has been done, right? So there is a
Exactly.
trade-off between these two. So Agile just promotes giving emphasis to people over the extensive documentation, but it doesn't say we don't need any documentation at all, right? So that's the
Right, right.
implicit one. Yeah.
But right, unfortunate part is people are getting into a tendency wherein they don't document at all. As
Yeah.
in,
So
the
yes.
person who writes the code is the only person who knows the code and how to debug it, kind of a thing. If
Yeah.
he
Yeah.
moves out or he moves into
Correct. Correct.
another role, or
Yeah.
that becomes a struggle for another person to get through.
Correct. Yes. Agree.
Yeah, and then same set of personnels are not going to work on the same thing for longer period of time. That's another problem with Agile,
Yeah.
as in if
Yeah.
people keep on rotating, then getting that knowledge base or getting up to speed
Correct.
on what needs to be done, that becomes another hurdle.
Yes. Yes. Correct.
Yeah, so there are and then people have started, as in typically the project management has started abusing Agile that way, I think. As in they don't bother about having documentation, they just want
Okay.
things to be done quickly. And then even on the last day of sprint or release, they kind of bring in requirement and they say that it's Agile, we should be flexible enough to absorb it.
Yeah,
Now,
so I think
yes,
yeah, so those are like yeah, the way this I mean there is this theory part and how you implement it and how much of it you understand and implement. So I think
correct.
the implementation of this has to be done with those cautions that you had called out. So I'm hoping yeah, with this course and the exposure that we are discussing and having, I think um, eventually all of you all may be into the managerial side as well soon or later. So I'm hoping it would be done better than like what you had called.
Right, and typically,
Yeah,
though Agile suggests that acceptance criteria and all should be in place, most of the time developers are the ones who start thinking about what all use cases should be there.
correct, correct. Yeah,
We get pretty stringent lines saying
yeah,
we need this, but in order to get that, you have 10 other use cases which one needs to think about, and then typically it becomes burden of development team to think about those use cases, get what needs to be done in those use cases, and then start development. So it eats
yeah,
up good amount of development time, which ideally should have been provided to development team in a way, I
correct,
think.
correct. Yeah,
So those are the wrong practices which are being
correct, correct.
kind
Yes,
of embraced in the name of agile. And people who kind of talk about this are marked as less flexible, if you say it so. They're
yeah,
not
correct.
agile kind of a thing. Don't think
Yeah,
in waterfall way kind of answer
yeah, yeah.
be
They are
thrown on you.
redefining yeah what is agility, true agility. But yeah, I think the yeah good call out and yeah I think yeah thank you for bringing up those points. So ideally yeah agile methodology and manifesto was not that, but it is being misinterpreted and done I mean implemented in r- you know incorrect ways. But yeah I think we all in this yeah class now understand the yeah true essence of it. So I'm hoping it will be better. And yeah, thank you so much for mentioning all these points. So with
Yuvraj,
that, yeah,
Right, right.
Yuvraj,
sorry.
one question here. As
Mhm.
you are saying, ki document team is not working across whole cycle. What they are doing during the cycle of the development? They are not working at all on the document.
No, no, documentation part as in the intermediate documents, as in design documents or
But
low level design documents. Those are not being prepared nowadays, at
but
least in my
at
organization.
least what I see in a practice, like document team is also following the same models. I mean, whatever the features they are implementing, parallelly they are writing the document for that, but not complete document.
It's
So
a
that
feature documentation, right?
yes,
What that feature is going to do, what all use cases are going
but
to be supported
no,
to some
they
degree.
are yeah they are going to follow the same thing. Once feature document is ready, they are going to integrate during the release time so that they will
Correct.
get the comprehensive document.
Yes, but that is from how that product or a feature needs to be used in a way,
Yeah,
right? It is not
yes,
going to talk about how it needs to be implemented. I'm talking about the intermediate part wherein architect and development team, those the documents which were prepared for by those teams for waterfall, those were valuable. Agreed that those were taking long amount of time, but now people have kind of short circuited it altogether. And
yes, yes,
there is always an urgency of delivery, barring even quality of software is not given that much attention, as in people are like, we have another sprint to fix it, so let's deliver it this way and fix it in the next sprint knowingly. Again, those are ill practices which are kind of being sold out in the name of agile, and
Yeah.
that's incorrect as per my understanding.
Yes,
y-
So
agree
Yuvraj,
to that.
that
You're right.
depends upon your particular project team also. So
That's
at
true.
certain
Hmm.
organization,
Yeah,
it is followed in proper manner. Like there is a documentation where we sign, okay, this is the starting phase, and even the sign off also is there where we mention, okay, these are the change requests, these are the features that we will be delivering, everything will be there. So it's not like the totally documents are, removed or something like that. It's how the team, the work method, मतलब team,
Correct,
how they are
correct,
working.
correct.
That depends upon
Yes, yes.
team, even dev team also. So we used to maintain those SOP documents, governance documents, and everything we are maintaining in Agile. Even scrums
That's
are
good.
written. Okay, this would be the frequency of the scrum calls.
Yeah, that's good then. Those are the right practices. As in, agile doesn't mean that we should short circuit everything and deliver fast.
Correct.
We should still have those practices, but in a meticulous way, wherein those are not going to hamper the speed with which we deliver, but at the same time, those are there as a safety net going further.
Yeah, well called out, and yeah, truly agree to that. You're right. So yeah, I think in the interest of time, we'll call it a
Call
day.
it a
And
day.
yeah,
Thank
thank
you.
you so much, Avran. Yeah,
Thank you.
have a good day. Thank you.
Thank you, sir. Bye.
Thank you, sir.